Okay, so welcome back everyone. Hopefully you are joining us again. I can see that you are, in fact. There's 62 people here. It's going up with every session. This is great. So I'm here with Michael. I'm just going to give everybody a few minutes to join and for all your video and audio to settle down, because we had a little bit of bother at the start of the last one where it didn't immediately come on. So if you just start saying hi in the chat when you can see us, that would be great. So Michael is going to be showing us how to do the cloud this time. Is that right?
Yes, well, towards the end of the talk, I'm going to catch up where we left off last time, and then hopefully we'll get towards the cloud at the end.
Great. Okay. Yeah, we're getting confirmations that they can all see and hear us, so this is wonderful. I'm going to hand it over to you, Michael, and we can get stuck in.
Brilliant. Hi, everybody. Hope you've been enjoying this second day of LiveCode Global. As you can imagine, it's a bit busy in the office at the moment, so I haven't had a chance to catch up on all the talks. But I'll do that later, particularly Trevor's one on Lavur. It seems something that's actually very interesting. Anyhow, this talk is the second in a series of talks in databases where we'll create an app with a local database backend and then work on moving that database backend up into the cloud. Now, if you haven't seen part one, you can catch up on that by going to the account area of the LiveCode website, where you'll be able to see all of the day one's talks. But in case, just to help you out, I'll go through a quick recap at this very beginning before touching on moving the app into the cloud, and then that'll move on to that'll link into the third part of the talk, which is to come. So let's get started. Where we were before. What is a database? Well, a database is just a structured collection of data. It can be a CSV file, collection of XML files, anything that kind of holds data in a structured way. In particular, we are talking about relational databases. And what is a relational database? Well, it has a database schema. That's a collection of tables. Database contents, that's the rows within those tables. A language to query the database. In this case, we'll talk about SQL, structured query language, or sometimes called SQL, and a database engine. That's the actual bit that does all the work that interprets the SQL, stores the data, and then returns the data. Now, when you're talking about databases in LiveCode, we use RevDB. RevDB is an external which allows you to execute SQL and get data into and out of a database. So, last time we talked about database types. There's two broad types that we'll consider for this talk. A local database type, this is something like SQLite, where the data is stored on your local machine. It's essentially a file, and it's a single user database. So that's good for creating a single user app, which we talked about last time, which is going to be nice and neat and contained. A server database, something like MySQL, Postgres, something like that. It's a multi-user app. It's hosted on a server usually. It has extra software running. It's quite complicated, but allows for much larger, much more scalable operations. And that's where we'll kind of come on to the second part of the talk, where we'll talk about moving it into the cloud. So in our first part, we created a simple notes app, which was a really very basic thing, but just illustrated the base properties, base principles of SQL and how you go about doing that in LiveCode. And as mentioned, you use RevDB. So the first thing you need to do is create a SQLite database. Now, as I mentioned, that's a local database stored in file on the local server. So we need to on the local machine. So we need to choose a location for our database. Now, last time we talked about where you want to do it, where you want to store the database. If it's a file on a mobile device or a file on your local machine, it's slightly different. And in case you might want to store it when you're developing in a slightly different location, so you can easily access it as well. So for mobile apps, it's good to store it in the special folder path documents, and on desktop apps, you can probably store it in special folder path preferences, and when you're actually developing locally, maybe you can put it on the desktop or somewhere where you can access it easily to look at the contents. Now you open the connection to the database using RevOpen Database. That gives you a unique ID, which is a handle to that database, and then you can use that unique ID for all future database operations. Now, something that we did last time, which was quite nice, is creating the database schema. Now I'll go through the database schema in the next slide, but basically you can store that in a custom property and run that database schema in the first run, so make sure that your database is set up all nicely. So when the app is first started, it's all pre-populated and has all the tables that you want. So here was our database schema. It was a very simple notes table. Each note had a title, a body, a created date, an edited date, and an ID, which is uniquely assigned to each note. So each first note we create will be ID number 1, second note will be ID number 2, and so on and so forth. How do we get something into the notes table? Well, we need to insert, and the insert command is insert into notes, and then the fields we want to populate, the title, the body, the created date, the edited date, and then the values that we want to insert into here: note title, note body. Notice here, date time now, that's for the created date and the edited date. Those are SQLite functions that return the current date and time. That's just a nice convenience handler rather than having to fetch the date and time yourself using LiveCode. And then once we've inserted data into the database, we need to get it back. That's where we use this SQL command, select star from notes. That'll return all the information from the notes table. It's very simple. And once we have an existing note, we might want to update it. So this is the SQL command for updating. Update the notes table, set the title to equal the new title, the body to equal the new body, where the ID is 123. So that's the unique ID for that given note, 123 being the ID number. So that's each time a note is added, it's incremented. So we just need to make sure we update the correct note by using the correct ID. Another thing we touched on in the first talk was using Unicode. Now the encoding of text in LiveCode fields is not always fixed. Sometimes it's native, sometimes it contains multi-byte characters or Unicode characters. So before you insert, make sure you text encode it to UTF-8 in this case, and also run pragma encoding UTF-8. That's an SQL command which will tell our SQLite database that we're expecting UTF-8 encoded text. And similarly, when we're getting data out of the database, make sure we text decode back into LiveCode text, which then means it's ready and usable by LiveCode. We can put it in and out of fields. Another thing we touched on was SQL Injection, which is a case where somebody can inject SQL directly into your command. So this is a case where they maybe type a quotation mark and then type something afterwards. What that will do is that will escape your SQL command, and then all of a sudden it runs the SQL directly afterwards that the user may have entered. So for example here, they enter the title of their note, my note, and then put a little quote mark and a semicolon, and then do delete from notes. That will run delete from notes, and it will delete all the contents of the notes table. It can also be just entered innocently. Somebody might enter a quotation mark as part of their name or the note title or so on. So how you get around that? You use placeholders. So we notice our rev execute SQL command, database connection ID, that's the unique connection ID I mentioned. And then our insert command has placeholders, :1 and :2. So rather than putting p title and p body directly into the query, we use :1 and :2, and then pass p by title and p body to rev execute SQL. And what revdb will do with those two is make sure they're properly escaped. It will use the correct escape characters to make sure that any quotation marks or any nasty characters within there are handled properly. So in the case of somebody enters the note title, my note, delete star from notes, that will be the title of the note rather than executing that piece of SQL. And the final part that we went on was developing a database library. Now, as we sort of developed our little notes app, we found that there was a lot of sort of common code that we were doing again and again. And this is something that I've found as I develop database apps. There's very sort of similar tasks that you're doing throughout the development process, and quite common things that are often shared between apps. So it's nice to create a database library that will promote reuse of code. It will speed up the development, and you can put that into a simple script on the stack and place it in the message path using start using. So these are some of the commands that we'd inserted into our database library. Connecting, which is libdb connect, that's a wrapper around rev open database, and it means that our libdb, our database library, now manages a connection ID. So all future libdb commands use that connection ID, so you don't need to concern yourself with the connection ID. And all our libdb commands will throw an exception on failure. That's just the way we implemented it. And same with libdb close connection. That's a wrapper around rev close database, and that closes connection to the database. Incidentally, the DB Connect for our SQLite database, we only really are concerned about the first two parameters, ptype and phost, where ptype is SQLite and phost is the file name of our SQL database. When we come on to working on the cloud, we'll talk a bit more about the further parameters and where they are appropriate. So here's an example, libdb connect SQLite, or in the title of our database. This is notes.db, and if there's any errors occurred, we do a try and catch bot to make sure we handle anything that's gone wrong. So revdb will return errors in the form of revdb error, and we need to parse. What libdb does is parses that error and throws an exception if it finds it. Similarly, if we want to execute an SQL statement, we use libdb execute. That is a wrapper around rev execute SQL, and you can pass any placeholders as parameters to libdb execute, and it returns a result with query or, again, exception on failure. So, for example, this is the first statement we executed in our little app, which was setting the getting the uDatabase schema, the uDatabase schema being a custom property of the stack, and the database schema that containing the schema of our database, which is create table notes. That was the first thing we did. We ran libdb execute, created our database, pre-populated it, and then we handle any error there. Then there's inserting data into the database. Now, we saw earlier the insert command, insert into, but a much easier and simpler way to do it would be to pass just the table name and an array of data. So rather than having to build the query each time, which is a bit awkward and a bit of a fiddle, we just pass the table name and the data. The data is just an array with key values. This builds the insert query for us. And the little nice feature that we talked about last time was *f for functions before the key name. That will mean that functions are handled correctly. I'll explain that in the next slide. So you see here, we build the first, at the top here, we build our data array, local tdata, put note title into tdata title, put note body into tdata body, and then our functions, date time now into the created date and edited date, and notice they're prefixed with *f. That's what I mentioned previously. That means that they won't be escaped properly. Using placeholders will be inserted directly into the query. So if we didn't put *f, the quotation marks there, the single quotes would be escaped, and that would then all of a sudden break things for the created date and edited date fields. We run libdb insert, and as mentioned in the previous slide, the result returned from libdb is the ID of the note that's just been created. So as I mentioned earlier, each note is given a unique ID, 1, 2, 3, 4, and so on, and that's the note ID that's returned by libdb insert. And once we've got a table, once we've got notes into the table, we might want to update them. And same again, you saw the update query before, update table notes, set field to equal value. Rather than building that query each time, we can just run a nice simple command which builds it for you. You pass the table name, and the same again, a data array, it builds a query for you. You pass the ID of the note you want to update, or the value you want, the row you want to update, and it will return the number of rows that have been updated. So an example here, new note title, new note body in the data array. Again, the edited date, make sure we update that. Call libdb update, the notes table, pass the data, and 1, 2, 3 is the ID of the note that we want to update. It's just an example here of that. So finally, we want to actually get data from the database. So we use libdata fetches text, which is a wrapper around rev data from query. And like before, you pass the query directly and any placeholders that you want to do. And what this will do is return the data or the rows as CSV. This is good for fetching a single piece of text, maybe give me the title of a given note or give me the edited date of a given note, but it's not very useful if you want to fetch more complex data, for example, data that contains commas or returns, because that will break our CSV format. In that case, we want to use libdb fetches array, which is the same, similar, but this time it returns the data as a 2-dimensional array, with the first dimension being an integer index of all the rows, and the second dimension being the key value pairs. So that's just like a DataGrade's DG data property. So an example for select star from notes, it will return 1, 2, 3, 4, 5 as the first dimension if there's 5 notes, and then row number 1 would be title equals as an array. So an example of that is set the DG data of group notes to libdb fetch array select star from notes. That was a really nice little thing we could do. We could really easily populate a data grid using the contents of our notes database using libdb fetches array, and an example using libdb fetches text, where we just want to fetch a single title, just a single field, quickly and easily. Rather than having it returned as an array, we can just return it directly as text, and that will put select title from notes where ID equals :1, and our ID is 123. Notice the use of placeholders as mentioned before, and that gives us the note title in the note title. So that's us caught up with where we were previously. What I can do is, if there's any questions on that, I'm happy to take them, or if not, I can continue on with with the next section.
Okay, so we do have a question here from Alex.
Sure.
He's saying, why CSV, why not TSV?
Exactly. Rev, if I go back to fetches text, actually this is a wrapper around Rev data from query, and you can tell the separators to be any format you want. I just used CSV for the example of for our libdb, but you can make them any format you want, and it will mean that you can include commas in your data rather than tabs, which would make things a bit easier. But really, a much better method is to use libdb fetches array, where it uses the rev query as database revdb function, and then pulls out each individual value and puts that into an array. That'll give you if you're fetching complex data, that's a much better way to do it, rather than fetching CSV data. It works, but or TSV data, or any data separated as text. It works, but it's a bit limited in its use. You'll kind of find that you reach its limits pretty quickly as soon as you start working on a slightly more in-depth app. Any more questions?
Jonathan says, I use num to char 28, 29, 30, and 31 as delimiters in my DB. Works for me so far. Are any risks to that?
You can use particular. Is he talking about? I presume he's talking about libdb fetches text. Again, or sorry, rev data fetch from query and returning it as text value. It will work, and you can use particular values to separate things, and that will work to an extent until you all of a sudden find that those particular values are in your database. As I say, it's a much cleaner way to use arrays. It will just gives you you're much better future-proofed, because you never know one day when that particular character might be used within your database. That might cause a little bit of confusion, and all of a sudden you have to debug and find out what's going wrong. So you really know what's going on, and then finally you track it down to that character is being used within your database, and it's clashing with your separating characters, which is a bit of a pain, because you then have to go and change that back, and then maybe at that point you move to an array structure for fetching from the database rather than doing it from the outset. So as I say, I recommend from the outset using arrays to fetch information, or using rev query database to fetch data from your database rather than fetching it as text. Okay, I'll move on to the next section, which is searching. So we talked about fetching information from the database using select star from notes, but maybe we want to fetch or search the contents of the database a bit more particularly. Rather than returning all the notes in the database, we just want to return a particular subset. So you notice the where keyword in our select statement here, select star from notes where title equals foo. Now that will return all the notes, as you'd expect, whose title is foo, and that makes sense. But it's kind of a bit limited. It's not really a search. All you're doing is returning notes whose specific title is foo. What happens if we want to kind of do a wider search, as in notes who just contain foo? Well, we can use the like command in SQL. So you notice here, select star from notes where title is like foo. Now we've surrounded it by percentage. The percentage symbol each side, that is a wildcard that will match any sequence of characters. So essentially, if a note title contains foo anywhere within that title, those notes will match and be returned by our select statement. And then finally, maybe we just don't want to search only on the title, we maybe also want to search the body of a note. So again, we can use select star from notes where title is like foo, but also we can extend it using Boolean operators and or. In this case, we'll use or. Either the title matches the foo or the body matches foo. So we can do or body is like percentage foo percentage, where the percentage matches wild cards. So if we go to our notes app, you may remember this from last time. Here we've got these are just a selection of notes that we've got in our database. I've just pre-populated with a few, and we've got now a field that allows us to search and a query button. So if we look at the query button, if the search term is empty, that will just return all the notes in the database. It calls fetch notes like we had before, so that's exactly what happens now. This is all notes in the database. If the search field is not empty, then we search on the contents of field search. So let's see what search notes does. So search notes is a function. We pass the search term to it. First thing we do, put percentage symbol before and after the search term. Then we build our query like we did in the slides. Select star from notes where title is like :1 or body is like :1. Notice this use of the placeholders again. And then we pass that to libdb, fetch as array, pass our query, that's select star and so on, and our search term is what's passed from the contents of the field, and that matches :1 in this case, so that'll be used as the placeholder, and it'll return the array, which is the contents of the database. So just a quick example there. Notice note 1, 2, and 3, they all have note in the title and the body. So if I type in note and query, that'll return note 1, 2, and 3. If I type in 12, return note 12. And if I type in say just 1, that matches note 1 and note 12 because they've both got 1 in it. So that's kind of a very simple example of how we might want to search our database and reduce specific notes. So that's a really simple way that somebody can search for a particular note using the like command and placeholders and the percentage to match any character. Now you might want to extend this a little bit by searching each individual word. So for example, somebody might type foo bar. You might want to consider that matches foo or bar essentially. So at the moment this should only return notes which contain foo bar exactly, but you might want to match notes which contain foo, hello world, bar, i.e. something in between the two words. So what you do in that case is extend our search notes function, so that it parses all the words within the search term and then places % symbols around those, and that will match anything. So that will essentially match each individual word. So that's a very simple way to extend search to give it a bit more functionality. So that's searching covered. Next thing we might want to do is to extend our app with more tables. Now at this point we've only ever used a single table, which is a notes table, but let's say we want to add attachments to our notes. For example, maybe an image or a file or something like that. Well, a simple way to do that is to create a new attachments table. Now you might be wondering why we don't add just a new field to the notes table, which is for attachments. And that would work, but that would mean that a note can only ever have one attachment directly to it, one attachment attached to it, if you will. So for example, a note only has one title, only has one body, and only have one attachment if we add an attachment field to the notes table. But if we create a separate attachments table, then a note can have several attachments mapped to it. And the way we do that is using the note ID. So I'll show you what our attachments table looks like. So like our notes table, each attachment has a unique ID. We use the auto increment keyword there to make sure that each attachment is given a unique ID on insert. The next thing we have is note ID. Now this is the interesting bit. This is the ID of the note that the attachment is attached to or mapped to. I'll show you that in a little diagram in the next slide. Then the next type is the next field is the type of the attachment. So we can say it's an image, or it's a Word document, or whatever CSV file, XML, whatever you want to attach to it. And finally, that's the actual core data, which is the attachment data, which is a blob. I'll discuss that in a second. So if we look at our two tables here, we've got our notes table. Each note has an ID, title, body, created date, edited date, and each attachment has an ID, a note ID, a type, and a body. So when we create our attachment, what we'll do is make sure we create the note, or we set the note ID so it maps back to the note that we want to attach or map this attachment to. Equally, when we want to fetch all the attachments for a given note, we can run select star from attachments where note ID equals 1234, 1234 being the ID of our note. So that's kind of the way that we can map more than one piece of data to a note. So there might be several, so you can see there might be several entries in the attachments table with note ID 1234. That would indicate that that note 1234 has several attachments. So it may have an image and a Word document or a PDF or something attached to it, several things, more than just one. The final part that we notice there is that the attachment data is stored as a blob. Now, we haven't seen blobs before. We've only really seen integer, text, and date time as the database types. This time we're using blob. Now, blob means that the data is binary, i.e. it's a file that we just want to treat as sort of a block of data rather than text that we're going to be editing or searching on. So binary is a special case and needs to be treated as such when you're handling it, when you're inserting and when you're fetching. Now the way we do that is use the star B placeholder. So we saw that with functions earlier. We used star F when we were inserting the date time function. This time we use star B when we're using binary data, and that tells RevDB that the data coming in is binary. It will handle it appropriately and make sure it's inserted into the database correctly and fetched from the database correctly. So that combined with the blob type there will mean that all our binary data is handled correctly. So let's go back to our Notes app. So this is our create screen here, and you'll notice I've extended it to allow adding of attachments. So let's just do a new note, with an attachment, and let's get a simple screenshot here. It's an image. This will be our attachment. So if we now create our note, let's look at the create note button. So this time we build up an array of attachments. Now we're only using one attachment here, so it's only going to ever have one thing, but you could, in theory, we could have as many attachments as we want. What we do is we create our array T attachments by putting the contents of the attachment, URL bin file, field attachment here contains the path to our file here. We put that into the array T attachments, and then we call create note with the title, the body as we had done previously, this time our array of attachments. So let's have a quick look at create note. So exactly as before, we build up the data array and we insert it into our notes table. So we've now created a brand new note. So notice that in the result value, that's our note ID. So libdb insert, the definition here, that builds up our insert query, and then it returns the last insert ID. So that's the ID of the note that's just been created. So we put that in tNote ID. And the next thing we need to do is build our attachment insert command. So what we do is repeat for each element in p attachments. So p attachments, remember, is an array of attachments. In this case, we've only got one, but it can be any number of attachments. And we build our data array exactly as we did with our note. Put the note ID into the T attachment data note ID, so that makes sure it's mapped to the appropriate note. Put type as image. In this case, we're only concerned with images, but we'd maybe pass that up if we're passing maybe PDF files or so on, and then put the actual attachment data, in this case T attachment, into the data field. And notice we prefixed it with star B there. And we just call libdb insert exactly as before into the attachments file, the attachments table, passing the attachment data. So now we've got an entry in our attachments database, and that note will have an attachment mapped to it. So if we just quickly click edit, you can see this is the image that we just took a screenshot of that was on my desktop. That's the attachment fetched to, mapped to that note. So let me show you what happens here. This calls fetch notes. This is in the pre-open card handler. So it calls fetch note, which returns an array of attachment of note data, the title, the body, and all the attachments. So let's have a look at fetch note to see what it does. So we pass the ID of the note that we want to fetch, and exactly as before, as we did part 1, we just fetch the note information from the notes table for that given ID. Select star from notes, where ID equals :1 and :1 maps to PID using our placeholder. Now there will only ever be one note returned. libdb fetches array returns and then integer indexed array, 1 being the first note returned, 2 being the second, but we know there's only one note with that particular ID, so we can just put tnote1 into tnote. So now we've got an array of notes. So let's do that directly, actually, and we'll see. So tnote is an array. The first element is our note data. So if we now put tnote1 into tnote, now we've just got a simple array with the single note that we want. The next thing we do is we want to get all the attachments mapped to that note. So like we had in our slide, select star from attachments where note ID equals :1, and we know what the note ID is, it's PID. So if we run that command here, we notice that the it variable now contains the data for the note. That's the raw binary data, the ID of the note, the data for the attachment, the ID for the attachment, the note ID that's mapped to that's 5, doesn't really matter, and the type. So that's all the attachments mapped to that note, and what we do is we put that into tnote attachments. So now our tnote array has an array of all the attachments. There could be several attachments mapped to this, 1, 2, 3. In this case, it's just 1, and then we return that back to our card script here, which puts the title field into the field title, the body field into field body, and it sets the text of an image to the first attachment that we find, because we know there's only one image, one attachment in this case. So that's a really simple way to add attachments to your notes, and shows an example of using more than one table. Is there any questions at this point?
We have from Kathy. If my is there a way to lock it to read only? I don't want users to make any changes. At this moment, if a user has Adobe PDF app, the document can be changed.
I'm not entirely sure. I didn't quite catch that question fully, but it's making PDF read only, which I guess is, I suppose, slightly out of context. So I'm not entirely sure how you make a PDF read only if someone has a PDF editor app installed. Sorry, I can't quite answer that question. I'm not entirely sure how you would do that. Yeah, without encrypting it, I suppose, but I don't really know much about the PDF spec directly, unfortunately. Any other questions?
There don't appear to be any others. No, that's it for the moment.
Brilliant. Okay, I shall move on to the next section, which is adding categories. So we might want a way to categorize our apps, similar to sort of attachments. We might want to map a category to our note. Now we can, what we'll do is something very similar to what we did with attachments, which is create a new categories table, but this time we'll also add a mapping table, which will map notes to categories. So I'll show you what that looks like here. We create a table categories, which again is just like we've seen before, ID and title. And then we create a table of notes to categories, which has an ID, which again, as we've seen before, but this time it has a note ID and a category ID. Now, this is a little different from what we saw with attachments. This is using sort of a third table, which is an in-between table. So in our little diagram here, we've got our notes on the left-hand side, which is, as we've seen before, and our categories on the right-hand side here, which just has an ID and a title. But this time we've got an intermediate table in the middle, which performs the mapping. Now, why would we want to do this as opposed to just having the categories table directly point to the notes table? Well, that allows for multiple notes to be mapped to the same category, essentially. So, for example, say we have a category called red. We might want to colorize our notes, so we have a red category. Several notes might be mapped to that category. So having this middle table means that we can have just a single entry for the red category, but several entries in the notes to category, which maps the red category to several notes, but we only have one note. So that kind of allows, this intermediate table allows a category to be mapped to multiple notes. So say we want to fetch all the categories that a note belongs to. This is where we do something called an SQL join. Now, an SQL join is something that's very powerful, and you might have heard of it before. And it's can be a little confusing at first, but it's actually quite simple when you look at it. So what we want to do with this query here is fetch all the categories that are mapped to note 1, 2, 3. So we do select categories.title, that returns the title of the category. So we see down here we have the categories table, and when we suffix it with .title, that means we get the title from the categories table. And then so select categories.title from notes to categories and categories. So these are the two tables that we're concerned with, the two tables that we want to join. And this is the where command here performs the actual join. So where notes to categories.category ID equals categories.id. So each category has a unique ID, and that, if you look at our previous table, maps back to the notes to categories category ID entry, or field rather. So that's how you do that. Notes to categories.category ID equals categories.id, and notes to categories.note ID equals 1, 2, 3. So that's saying we want to fetch all the categories that belong to note 1, 2, 3. So we've got on the left hand side here we have note 1, 2, 3, and on the right hand side here we have a whole list of categories. We can have several of them. So what we do is we look up for all the entries in the notes to categories table where note ID equals 1, 2, 3, and then fetch all the categories whose category ID matches to that. So that's what our join here is doing. And it's a little bit confusing at first, but once you kind of begin to understand it, it'll begin to make sense. Now, a little bit more complicated is we want to filter by category. That is, we want to find all the notes who belong to category red. So this time, instead of just operating on two tables, we're operating on all three tables: notes, notes to categories, and categories. And we want to fetch notes.star. Now .star, that means it returns everything from the notes table. So like we did before, we can use the dot suffix to fetch given particular fields from the given table. So this time we do something similar. We want to match the note ID to the notes to categories note ID, the category ID to the notes to category ID. We want to match the category title to red. So if we go back to our little example, or our little diagram here, we have categories here, which this time there'll be several of them, but we're only concerned with one of them, red. So we want to find all the notes to categories entry whose category ID matches to the red category, and then there'll be several note IDs with that, and they'll map back to entries in the notes table. So to make this a little bit clearer, let's see what we have in our app. I'll bring up the next part, which has categories in it. So this time, let's go and look at creating a note with categories. So Let's, I've pre-populated this with 3 categories, red, green, and blue. Let's just add red and green to the category list. Let's create our note here. Let's have a look at what it does. Like before, it deals with attachments. Where the attachments is an array, this time we'll have an empty array. We also pass field categories, so this will just be a return separated list of categories. So if we step into create note does exactly as we had before. Creates our note entry in the notes table, adds all the attachments, and then exactly the same way, it creates the entries in the categories table and the notes to categories table. So we create a category mapping, we put the note ID in there, and then notice that T category here, or P categories, is just a list of category titles, but what we want is category IDs. That's what we have in our table, notes to categories. If we look at our table here, it's category ID that sits in that table rather than category title. So we have a little helper function here, which returns the category ID from the title. All that does, select ID from categories where the title is column 1. So we pass the ID of the category, we pass the title of the category, in this case red, it will return the ID of the category. So let's now get our category mapping array. Category ID is 1, which is so happens to be the ID of the red note, the ID of the red category. And insert that into notes categories, just like we did before. And then we'll also look at, we'll also add greens or second category. This time the green category is ID 2, and that inserts that into notes categories. Now if we go to our...
We are having a bit of a problem with the audio here, Michael.
We are?
Is that better?
Sorry. Is that okay? Continue on.
Yeah, I'm not sure what happened there. But anyway, whatever you're doing now, just keep doing that because that's much better.
All right, I shall. So before, in case you missed any of that, we were just inserting the category into the notes to category table. So now we go to our listing card that we had before, and I've just pre-populated it, and that's our new one here, which has the various categories mapped to it. So we can do our filter command, we can find all our red ones, filter, and that'll return the red ones, all the green ones there, filter, that'll return the green ones. So let's have a look at what our filter button is doing here. So it's calling filter notes by category and passing the label of button category list, which is just our little button down here. So on that, we pass, so filter notes by category is a function, and we pass the category we want to filter on, and then we build our query, which is what we talked about in our slide before. It's our join, which joins the notes table to the categories table by the intermediate notes to categories table, and that will return all the notes whose category in this case is green. So let's just run that. Call libdb fetches array, passing p category as a placeholder. Notice that key categories.title is our placeholder there. And that returns our array, which will get passed back directly to our button script, button filter, which will then return all the categories, all the notes who's been categorized as green or red or so on and so forth. So that shows you how we can use an intermediate table and joins within SQL to map various things up. And it's kind of a little bit complicated, but it's a really powerful feature as part of SQL, which is something that you probably, once you slowly begin to develop database apps, you'll get more and more familiar with and more used to using. So the final part before we finish up is talking about moving our app to the cloud and how we've actually structured our app. So if you look at our app at the moment, we have our user interface that talks to libdb, which in turn talks to revdb, which talks to SQLite. So that's kind of the basic structure of our app at the moment. Now that works very nicely for what we've got at the moment. We've kind of got a degree of separation, which is nice and clean. But each individual bit does its own individual task, which is kind of exactly what you want with application design. But it's a little bit limiting because if we want to move our app to the cloud and move our database elsewhere, it's a little bit tricky because essentially now we have to sort of redo this layer after the user interface. This whole section needs to be rewritten so it now talks to the cloud directly rather than talking to libdb. Now, a nice way that we can sort of get around that and work around that is to use an intermediate data layer. Now, what that is, it's a nice simple layer that sits in between the user interface and libdb. It completely separates the user interface from the database. So rather than our interface commands calling libdb directly, they call a data layer. So it kind of abstracts the notion of the data store. So rather than the data being stored directly in a database, it's stored now in this data layer. And the data layer could be anything. In this case, for our first example, it's an SQLite database, but it could actually be text files, or as we move on to the next talk, a server-side database. So that kind of intermediate layer, our data layer that sits in between our user interface, and in this case, libdb, that handles sort of storing the data. So it's kind of an abstraction in this and it will show you why that's a really useful way to go in the next slide. So we've got our user interface, it talks to our data layer. Our data layer here talks to libdb, which like before talks to revdb, talks to our SQLite database. But when we want to move things into the cloud, what happens is our user interface talks to the data layer. Now the data layer, the API of the data layer is exactly the same. The user interface doesn't need to change at all. It's dealing with the data layer exactly as before. But this time what we do is we modify our data layer. And what the data layer does is talks to a web service over HTTPS, which then talks to libdb, which then talks to revdb, which then talks to our SQL database. In this case, on our server, it will most likely be MySQL. Now, what that does for us is it means that our user interface doesn't need to change at all. And libdb and revdb doesn't need to change at all. That works exactly the same way. All that needs to be inserted is a new data layer and a new web service, which handles the communication between the two. So I'll kind of briefly show you how that works in our app. And it's really simple.
I just have to mention, Michael, we are actually at 1 minute to 5. Right. So briefly.
Yep, this is the last part, and it's actually very simple.
Okay.
So if we look at our stack script where we had a lot of our commands that we're dealing with, creating and editing and fetching notes, this time instead of executing the revdb commands directly, we call libDataLayer create note. So here, before we had revdb commands, this time we call the data layer commands. And it's the same for all of them. Essentially, I've just pushed all the database functionality into libDataLayer, which is, if you look at our project browser, is a substack of our main stack called libDataLayer, and all we do is we start using that stack, which will put it into the message path. And if you look at the code, libDataLayer does exactly what we had in our stack script before. It connects to the database. We have libDataLayer create note, and that this time it executes the SQL, which inserts a note exactly as we did previously. Now, why this is useful is our UI, our stack script, talks to libDataLayer, but say we want to move libDataLayer, instead of using a local database, we move that to the cloud. All we need to do is replace our substack here, libDataLayer, with a new substack which talks to our cloud web service. Our UI and our stack script doesn't need to change at all. The API is exactly the same as before, but this time libDataLayer has changed. So instead of directly inserting into the database, it talks to our web service over HTTPS, and then the web service will run this exact functionality. So that's the beauty of using LiveCode Server to build your web service. you can run these exact commands on the server side to insert into the database. So you can create the database on the server, it exists there, and the web service just runs these commands. It runs libdb and it functions exactly as before, but there's just this data layer in between which handles communicating between your local app and the server app. And that's what we'll do in the third part. We'll go on to building that web service and building the data layer, and I'll show you how easy it is to modify our simple local database app to making it exist on the cloud. So that's us pretty much done. If you have any questions, I can answer them in the Slack channel, but I think we're now ready to move on to the next talk, which I believe is Kevin's talk.
Fantastic. That was great, Michael. Really interesting. I even followed some of that, so thank you. Yes, we have Kevin up next. So I'm going to end this one and I will start the next one as always. If you guys want to go and check your email to look for the next link so that you can rejoin us or refresh your web page, make sure you're joining the right session. We had a couple of people there with difficulties joining. Mike is saying, yes, that was fast. Yes, we're running out of time a little bit. So, of course, you will get the recording. You'll get all the materials. And do head on over to Slack now and you can quiz Michael thoroughly on anything you want to know. So I'm going to end and start. I'll see you all again in a few minutes.